this webinar will get introduced to the AWS security. What are the various services offered or tools available in the AWS suite provided by AWS. What will be the cost and effectiveness? What are the how can we protect our assets if we choose AWS? So we'll go through various aspects like starting with AWS certification structure, like what various aspects covered, or what are the certifications offered by AWS, and what are various degrees of the certifications they categorize themselves. Then AWS organizations, like how they categorize their structure, and shared responsibility model, where responsibility is shared between AWS and its clients. And we'll go we'll go through each one of them. At the end of this session, you'll know the overview of cloud security or its components of available in AWS, and we'll get introduced to the AWS infrastructure, how it is structured, and the various policies and controls designed by AWS, and we'll quickly go through the usage of basic tools and services to protect the web service or a web page. Coming to the structure of the AWS certifications, there are four categories or divisions made available. One, starting with the fundamental. These are entry-level certifications. It will take about 6 months to prepare, even less. Then coming to the associate, this is for engineers who worked on AWS platforms like developers, DevOps, system admins, etc. Then coming to professional ones, these certifications are categorized for people who have worked in AWS extensively. So they have delivered solutions or cloud-based products from a longer point of time, like 2 years or 3 years of time. That's a professional certification category. Then coming to the last one, it's a specialty certification where two or more domain knowledge are required. And our AWS certified security specialty, right? It comes under a specialty certification because security, this particular security domain need multiple domain knowledge. I'll just show up the AWS management console. So to access the assets of AWS, we need to first log into AWS management console. Okay. After that, you will get this screen. Here you can see some of the build a solution like EC2 instance, build a website. How these are some of the solutions. Or we can get a search bar where we can, if you know what service you want, such as an IAM service or a WAF service, you can type it here. Else you can scroll down to the scroll to the services tab and click on the drop down where you can find all available services here. So these are all the available services with support to build a solution. Of these will browse through the AWS services which support security of our application. Organization. For AWS Organization, it is a structured approach for such a, where how to categorize various sections of our organization. Same as in um, um, Active Directory services in Windows, right, where we categorize the domain. Say in a similar fashion, AWS also tends to differentiate. Um, Starting with the root organization root, where admins and all activities are allowed. After that, organization units were created, where we can categorize those organization units like a HR team or an admin team, um, or a dev team, testing team. We can categorize. Then come to the concept of nested team within dev team. Say we have a organization unit as dev team. We can categorize various team within the OU. We can create multiple OUs like web development team. This as a mobile development team. We can categorize that, and so OU will be the organization structure where we'll structure various teams, and we can have member accounts. Okay, we can have a manager in the as a member of dev team as well as testing team, or we can have we can have a development lead who is part of all the development OUs, web and mobile. So OUs are the groups in terms of Active Directory groups, of which we can add and remove an user according to our needs. And we can create policies out of them. These OUs are allowed these activities, and these OUs are not allowed to these activities. That is, say, we can create policy such as the dev team is not allowed to deploy the code or access the resources in the deployment environment. That is for only testers. Or the testers are not allowed to access the code or edit the code or compile it. So that is for developers. So we can structure the our team. This is very helpful since AWS is allowing to structure our organization. We can replicate our existing structure within the AWS assets and categorize accordingly. This helps us save a lot of time because whatever the organization structures we are the product users in its company can be replicated and used as it is. And it's what are the available policies or procedures allowed, we can apply the same here. We're not trying to recreate the structure or starting from the scratch. No need to reinvent the wheel again. Coming to the shared responsibility. Say my website, for example, say my website is hosted in an AWS service, EC2 service. That is, it creates a virtual environment where my website can be hosted. So there will be a lot of responsibilities for that website: uptime, content, configurations, everything. So how it will be a shared responsibility. When I'm hosting my website in AWS, I hold some responsibilities and AWS holds some responsibilities. How these responsibilities are shared? This is the shared responsibility model. AWS is primarily responsible for hardware and its downtimes and its availabilities and any contingency policies or PCP plans. It's the AWS is responsible for that. And I, as a developer who hosted my website in AWS, is responsible for its configurations, encryptions, presentation layer, whatever is inside the container or the web web server information, right? It's on it falls on the developer. That is what server to use, how to configure it, what content to feed it, which type of encryption to choose, any protections or security measures required. That falls under customer. So since the security aspect, majority of the security aspect comes under customer, AWS provides various services and tools to protect our web service. So here, there are a plethora of tools based on our requirement we can use to protect our web service. These are provided by AWS because this responsibility falls on customer, not on AWS. AWS is helping or reducing the load of customer by providing these services. Another view of the shared model is, you can see in the bottom layer, this is managed by AWS and these are managed by customer. Here you can see the foundation services like the EC2 service, which is a container. So these are container services, storage, networking, and databases. That is, if my website is not able to communicate with the DB, then it's a networking issue. It falls under AWS. Okay. And the regions, say for contingency purposes, there are multiple sites for AWS. So zones, availability needs to be taken care by AWS. They have to plan and configure. So coming to the managed by customer end, at the network layer, network protection comes under customer, but the networking aspect is under AWS, but network protection is under customer, because AWS will configure and route the traffic, but protection will fall under customer, because based on the users customer is targeting and based on the requirement. And encryption, client-side or server-side encryption, like how the communication should go, like whether to use which protocol to use, TLS 1.3 or not. So these are the decisions that customer need to choose. So this increases the responsibility at the customer end. At the same time, it gives flexibility to the customer on what type of choices to make. That when this responsibility of encryption falls under customer, he have a lot of options there. Say the current version of TLS is 1.3. It is a encryption protocol between client and server. Okay. Say there is a vulnerability in 1.3, and they fixed it in 1.4. The customer can immediately migrate from 1.3 to 1.4 immediately. Customer have the responsibility. So that's why AWS offloads more responsibility as much as possible to the customer, so that customer will have the flexibility to which to choose or which not to choose. This will give a lot of choice to developer on how the product should be developed. We'll take a use case. The use case is we'll take a EC2 instance. EC2 is a service offered by AWS, and it creates a virtual environment. It will create a virtual machine. So we'll load. For this scenario use case, we take up an EC2 instance where a web server is installed. On top of that, my web page or website is hosted in it. So that in EC2 instance will act as a web server, which is hosting my website. Okay. For that website, how can we secure that particular website using tools and services offered by the AWS? that will be the use case. We'll go through it. We'll go through each and every service or tool offered by AWS for this particular use case, so that we'll get understanding like how that particular service or tool is helpful in protecting this website. The first one is identity access management. As we discussed before, we've seen the organization structure, overviews, nested overviews, members, how to add the members, and remove the members. This will help the organization to can easily replicate the existing structure and policies. So for that, this is IAM is a service where you can take it. It's an equivalent to Active Directory admin console. Okay, we'll log into IAM, create organization units, members, groups, and users, and provide permissions to them and set policies like this this group can do these activities. So this is admin console for structuring and restructuring and setting up policies as well. Coming to the first service, when a website is created, first one is to restrict the access to all the users. When my intended users, when my site is intended, say my website offers service to book train tickets. Okay, so for that, then that means it's not for everybody whoever need that particular service. So to restrict the access to my website, I can use AWS Cognito. This is a service which allows authentication and authorization of a user. That is, there are various options in it where it will create. Cognito will create a sign-in page for this, and user is expected to enter username and password. Cognito itself will check the identity of the user and authenticity of the user. Once the user is authenticated, then the user is expected to view particular pages only, not all the pages of the website. That is, the user who logs in is not allowed to do admin activities or to change the content in the website. So that is for admin. So the user will be based on his authorization policies set in IAM. Cognito will restrict the user to the resources whatever he is allowed to. And this comes under user, that is user activities. What are the resources user can access, and what are the resources user cannot access. And another section is identity pools, where within AWS there are a lot of services, as we've seen in the AWS management console, right? What are the services a user can use? These are determined in the identity pool. Single sign-on is, you can take it, it's a service, but it works in with Cognito, because Cognito takes control of authentication and authorization. So SSO will be part of it. So what is single sign-on? So single sign-on is a authenticating way. That is, once we enter username password and the user is authenticated successfully, for various services and features, user doesn't need to log in again multiple times. Once the user is successfully logged into the service or once, then he don't need to log in multiple times. So that is the single sign-on mechanism. So single sign-on is allowed. And So here is a small example illustrated here. So AWS SSO user portal will be there. You can choose any of the SSO applications, or you can directly hit the website. Here it is example.com. So from the user SSO portal, when the user tries to log into it, the service request will hit the example.com, that is the website. Then it will go, then it will send a SAML request for the authentication. So what are the username and password it is here, it will verify and it will get the response. If it is password is correct and user's identity is validated, then the SSO is successful and it will allow the user for rest of the services. Then the web application firewall. This is for a web application specifically, it is a very important service. A general firewall, that is a network firewall, will operate at network layer. That is, a firewall will recognize an IP and port. So in firewall rules, ACL, access control list, where we can see allow traffic or deny traffic from this particular IP with a port like with this particular port, that is 443. So that is how a network firewall is configured. But for a web application firewall, it have more access to upper layers of the OSI model. That is, it can access application layer. That is, this firewall, the web application firewall, can understand HTTPS, which operates on the application level. So we can configure rules not just with IP and port. We can configure with the protocols used at and various metrics at application layer, presentation layer. We can choose a particular rule to allow or deny with various metrics or measures within the application itself, such as protocols. So that gives a lot of flexibility. Say if I'm getting a particular malicious virus signature repeatedly from a user, so I can if I identify that particular malicious signature, I can block that particular signature, or I can block from that particular source IP where it is coming from. So else I can block all of the traffic from particular port. So we WAF at an application layer can operate or restrict access to individual traffic to the feature. Say my website have 10 features, okay, and one of the feature is say as we discussed, it is say I'm offering service to book a ticket, okay. So one of the particular service is getting the train available train information. So for that part, and when an attacker is trying to